written by Neil deGrasse Tyson. The idea of creating artificial beings with intelligence has captivated humanity for centuries. From the earliest days of civilization, humans have dreamed of creating life in their own image, beings that could think, reason, and perhaps even feel. Ancient myths speak of robots and artificial life. Stories from Greek mythology, like the tale of Talos, a giant automaton made of bronze, reflect these early fascinations. However, it wasn't until the mid-20th century that the dream of artificial intelligence began to take practical shape. The invention of the computer provided the necessary tools to turn these ancient dreams into reality. With the advent of computers, scientists and mathematicians started to explore the possibility of creating machines that could think. They began to develop algorithms and programs that could perform tasks previously thought to require human intelligence. Early AI systems were primarily rule-based. These systems followed strict sets of rules and instructions to perform specific tasks. These systems relied on predefined sets of instructions to solve problems. They were limited by the knowledge and creativity of their human programmers. They were like digital recipe books following specific steps to achieve a desired outcome. Each step had to be meticulously planned and coded. While these early systems showed promise, they were limited in their ability to adapt to new situations or learn from experience. They could not improve or evolve beyond their initial programming. These early machines, while primitive, laid the groundwork for the development of more sophisticated AI systems. They were the first steps on a long journey towards true artificial intelligence. They represented the first tentative steps towards creating machines that could mimic human thought processes. These pioneering efforts set the stage for the incredible advancements in AI that we see today. The year 1956 marked a pivotal moment in the history of artificial intelligence. It was a time when the world was on the brink of technological revolution and the seeds of AI were just beginning to take root. A group of visionary scientists gathered at Dartmouth College for a summer workshop. This was no ordinary meeting. It was a congregation of some of the most brilliant minds of the era, all driven by a common goal. This event, known as the Dartmouth Conference, is widely considered the birthplace of AI as a field of study. It was here that the foundational ideas and concepts that would shape the future of AI were first discussed and debated. The Dartmouth Conference brought together some of the brightest minds in computer science, including John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester. These pioneers were instrumental in laying the groundwork for what would become a transformative field. It was at this gathering that the term artificial intelligence was coined. This new term encapsulated the ambitious vision of creating machines capable of performing tasks that would typically require human intelligence. The goal was ambitious: to explore the possibility of creating machines that could simulate human intelligence in all its forms. This included reasoning, learning, problem-solving, and even understanding natural language. The Dartmouth Conference was a watershed moment. It marked the beginning of a new era in which the boundaries of what machines could do were being pushed further than ever before. It marked the beginning of a concerted effort to create machines that could think. This was the dawn of a new age, where the dream of intelligent machines began to take shape. While the goals set at Dartmouth seemed audacious at the time, they ignited a spark that would fuel decades of research and innovation. The legacy of the Dartmouth Conference continues to inspire and drive the field of artificial intelligence to this day. One of the most influential figures in the early days of AI was British mathematician and codebreaker Alan Turing. Even before the Dartmouth Conference, Turing had already been contemplating the question of machine intelligence. In his seminal 1950 paper, Computing Machinery and Intelligence, Turing proposed a test for determining whether a machine could exhibit intelligent behavior indistinguishable from that of a human. This test, now known as the Turing test, has become a benchmark in the field of AI. While the Turing test has been both influential and controversial, it highlights a fundamental challenge in AI, defining and measuring intelligence itself. Turing's work continues to inspire researchers to this day as they strive to create machines that can truly think. The 1960s and 1970s saw the development of expert systems. These systems were designed to mimic the decision-making abilities of human experts in specific domains. Using a vast database of knowledge and a set of rules, expert systems could diagnose diseases, recommend treatments, and even play chess at a high level. One of the most famous examples of an expert system was Dendral, developed at Stanford University. Dendral could analyze chemical data and identify unknown organic molecules, a task that previously required expert human chemists. However, expert systems had limitations. They were only as good as the rules and data they were given. They struggled to adapt to new situations or to learn from their mistakes. This highlighted the need for a more flexible and adaptable approach to AI. In the 1980s, a new paradigm emerged in AI machine learning. Instead of relying solely on pre-programmed rules, machine learning algorithms could learn from data. By analyzing vast datasets, these algorithms could identify patterns, make predictions, and improve their performance over time. This shift towards machine learning was driven in part by the increasing availability of data and computing power. As computers became more powerful and data became more abundant, researchers could develop and train more sophisticated machine learning models. Machine learning opened up new possibilities for AI. It paved the way for the development of algorithms that could recognize images, translate languages, and even drive cars. Section 6. Neural networks, mimicking the human brain. One of the most powerful approaches to machine learning is the use of artificial neural networks. Inspired by the structure of the human brain, neural networks are composed of interconnected nodes or neurons that process and transmit information. Neural networks had been studied since the early days of AI, but they had been limited by computational constraints. With the advent of more powerful computers and new training algorithms, neural networks experienced a resurgence in the late 20th century. Neural networks excel at tasks that involve pattern recognition, such as image classification and natural language processing. They have become a cornerstone of modern AI, powering a wide range of applications from facial recognition software to virtual assistants. Section 7. The Deep Learning Revolution, Unleashing the Power of Data. In the 2010s, a subfield of machine learning known as deep learning emerged as a dominant force in AI. Deep learning involves training artificial neural networks with multiple layers, allowing them to learn increasingly complex representations of data. This breakthrough was made possible by the availability of massive data sets, powerful GPUs for processing, and advances in training algorithms. Deep learning has led to remarkable breakthroughs in areas such as image recognition, natural language processing, and game playing. One of the most notable achievements in deep learning was the victory of AlphaGo, a program developed by Google DeepMind over a world champion Go player in 2016. This victory demonstrated the ability of deep learning systems to master complex games that had long been considered a challenge for AI. Section 8, AI Today, from self-driving cars to personalized medicine. Today, AI is transforming our world in countless ways. From the smartphones in our pockets to the algorithms that recommend products and services, AI is becoming an increasingly pervasive part of our lives. Self-driving cars, powered by AI algorithms, are already being tested on public roads. In healthcare, AI is being used to diagnose diseases, personalize treatment plans, and accelerate drug discovery. AI is also being used in finance, education, manufacturing, and countless other industries. The impact of AI on society is only beginning to be felt. As AI continues to evolve, it has the potential to solve some of the world's most pressing problems and create a more prosperous and equitable future for all. Section 9. The Future of AI, Promise and Peril. The future of AI is full of both promise and peril. As we stand on the brink of a new era, the possibilities seem endless yet fraught with challenges. On the one hand, AI has the potential to revolutionize many aspects of our lives for the better. Imagine a world where our homes are smarter, our cities more efficient, and our daily tasks simplified by intelligent systems. It could lead to breakthroughs in medicine, offering new treatments, and possibly even cures for diseases that have long plagued humanity. AI could enable us to address climate change more effectively by analyzing vast amounts of data to find sustainable solutions and optimize renewable energy sources. It can also automate dangerous or tedious tasks, making industries safer and more productive and freeing humans to focus on more creative and fulfilling endeavors. On the other hand, AI also poses significant risks. The rapid advancement of AI technology brings with it concerns that cannot be ignored. There are concerns about job displacement, as machines and algorithms take over roles traditionally held by humans. Additionally, algorithmic bias can perpetuate and even exacerbate social inequalities. The potential for AI to be used for malicious purposes, such as autonomous weapons or invasive surveillance, is a significant threat that must be addressed. As AI becomes more powerful, it is crucial that we develop ethical guidelines and regulations to ensure that it is used responsibly. Policymakers, technologists, and society at large must collaborate to create a framework that balances innovation with safety. The future of AI is not predetermined. It is a path that we must navigate with care and foresight. It is up to us to shape its development and ensure that it is used for the benefit of humanity. By fostering a culture of responsibility and ethical consideration, we can guide AI towards a future that serves all of us. By embracing the potential of AI while mitigating its risks, we can harness its power to improve our lives in countless ways. We can create a future where AI empowers us to reach our full potential as a species, driving progress and innovation while ensuring that no one is left behind.